Hello, it's Mr. Win again with part 2 of the chapter 10 test review. We're now on problem number 12. For 12 and 13, find the sum of each infinite geometric series if it exists. Remember, for infinite geometric series, we have to see if R is greater than 1 or less than 1, see if it's convergent or divergent. For number 12, R is 1/5 because that is less than 1. That is convergent. We can find a sum. That formula is, I'll write it right here. Sum of infinite is A1 over 1 minus R. So I plug that in. We get S of n equals A1, the first term. We have to plug that in. So we're plugging 1 for n. 10 times 1/5 to the 1 minus 1. That's 10 times 1/5 to the 0 power. Anything to the 0 power is 1. 10 times 1 is 10. So we know a sub 1 equals 10. So 10 goes here over 1 minus r. We can figure that out. It's pretty easy. That's 10 over 5 over 5 minus 1 over 5 is 4 over 5. If I have a fraction, I can do 10 divided by 4 over 5. We know you don't divide by fractions, you multiply reciprocal. So this is really 10 over 1 times 5 over 4. So that gives me 50 over 4, which reduces to 25 over 2. That is our sum. That is H. Alright, for 13 we do the exact same thing. So let's see, we can figure out what R is. R is not given, so we're going to do the second term over the first term. That's 4/5. So that's our R. That's good. That's times 4 over 5. We can check. 4 times 4 over 5 is 16 over 5. So because R again is less than 1, this is convergent, there will be a sum. If it's 1 or more, it's divergent, there is no sum. Alright, so now I'm going to use the formula. So I'm going to go back to this. I'm just going to fill it in. So a sub 1, we now have the first term. The first term is 5 over 1 minus 4 over 5. We can figure that out. You can type in calculator or you can do it by hand. 5 over 5 minus 4 over 5 is 1 over 5. This gives me 5 divided by 1/5. Again, we don't divide by fractions, we multiply reciprocal. So this is 5 over 1 times 5 over 1, which is 25. So the sum of that infinite geometric series is 25b. Alright, 14. Write 0.63 repeating as a fraction. So 0.63 repeating. So 0.63 repeating is really the decimal 0.63, 63, 63, and so on. We're going to break it up to say it's this number, 0.63, plus this number, 0.0063, plus this number, 0.00063, and so on. And so on. Alright, so notice this fraction is 63 over 100, plus this is 63 over 2 4 zeros, 10,000, and it repeats. If we find our R, we know R is actually 1 over 100. So now we can use the sum formula of a infinite geometric series. So this is S of n equals A1 over 1 minus R. Well, the first term was 63 over 100 divided by 1 minus 1 over 100. You could easily figure that out. So I'm going to go up here. That's 63 over 100 divided by 100 over 100 minus 1 over 100 is 99 over 100. We don't divide by fractions, multiply reciprocal. So this is 63 over 100 times 100 over 99. The 100s cancel out, so this is 63 over 99. If I divide it by 3, I get 21 over 33. If I divide it by 3 again, I would get 7 over 11, and that is my answer. That is F. Alright, for number 15, we have a recursive sequence. We just have to plug in n and use it. So let's let n equal 1. n equals 1, the formula becomes a of 1 plus 1 equals 2a sub 1 plus 1. So that really means a sub 2 equals 2. A sub 1, the answer is negative 1 plus 1. If I simplify that, that's negative 2 plus 1, which is negative 1. So now we're going to let n equals 2. So that means I'm plugging 2 for n in the formula. A sub 2 plus 1, meaning a of 3, equals 2a of 2 plus 2. So that means a sub 3, the third term would be 2. A of 2 we just found before was negative 1 in red, plus 2. If I simplify that, I get negative 2 plus 2, which is 0. Alright, so now let n equals 3. Let's find the fifth term. Alright. So the form becomes a sub 3 plus 1, meaning the fourth term will be 2 times a sub 3 plus 2. So that means a sub 4 is 2. A sub 3 we found before was 0 in red right above me, plus 2. Well, that is 2 times 0 is 0 plus 2. Just keep the trend using red. It's positive 2. Alright, then we find let n equals 4. So the form becomes a sub 4 plus 1 equals 2a sub 4 plus... Ooh, I messed up. Alright, let's go back to the last one. Right here, this should be not 2, but plus 3. So that's a quick fix. So this 2 turns to 3. So 0 plus 2 turns to 3. This makes this 3. There you go. Now we're back to normal. So 2 times a sub 4 plus n, which is 4. So really this is a sub 5, the fifth term, is 2 times 3, found red before, plus 4. So that is 6 plus 4, which turns into 10. So a sub 5, the fifth term, is 10. Answer is D. Last problem, 16. Find the third iterate of f of x equals x squared minus 3 for the initial value of x sub naught is 2. This is a composition. They're basically asking us to find f of 2. Alright, so y'all know how to do this. Find f of 2 first, we'll plug 2 in. So f of 2 I'll do over here is 2 squared minus 3. So that is 4 minus 3, which is negative 1, or positive 1. Positive 1. Alright, so I'm going to replace that inside with positive 1. So now we have f of positive 1, because positive 1 is the first iterate. Alright, so now I'm going to do this next problem, f of 1. So go over here, f of 1 means x is 1, so 1 squared minus 3, which is 1 minus 3, which simplifies to negative 2. That is the second iterate of this, so I'm going to replace that inside with negative 2. So now we find f of negative 2, so one last time. We're going to figure out what this thing is right here. F of negative 2 means plug negative 2 in for x, so negative 2 squared minus 3. Well, negative 2 times negative 2 is positive 4, minus 3 simplifies to positive 1, and that is our third iterate, 1. The answer here is H. And that's it for the Chapter 10 test review. Hope you enjoyed it. Hope you understand it. If you have any questions, ask in class. Thanks for watching. See you in class. Bye.